Imagine for a second that you're looking at this pristine, highly optimized executive dashboard.
Oh, yeah, the classic boardroom setup.
Right, like it is glowing on this massive monitor in a corporate boardroom. The charts are trending up. The production efficiency is sitting beautifully at exactly 100%.
It looks perfect.
Exactly. The data flows look perfectly seamless. You are the executive, right? And you feel just entirely in control of the whole operation.
Sure.
But now, taking an elevator down to the actual plant floor, you walk past all the heavy machinery, the noise, and you look under a floor engineer's desk.
And what do you find?
Well, down there, covered in just a thick layer of industrial dust,
Yeah.
is this 10-year-old Dell laptop. And its fan is just screaming.
I can hear it now.
Right. And you find out that all of that flawless dashboard data you just saw upstairs, it is entirely dependent on a single, completely undocumented Python script running on that specific dusty machine. If, like, a night cleaner accidentally unplugs that laptop to plug in a floor buffer or something, the entire facility halts. The dashboard just goes dark. And, well, that is the reality we're unpacking today.
It is a terrifying image, honestly. And the crazy thing is, it plays out in industrial environments all over the world, like every single day.
Which brings us to our mission for today. Welcome to today's deep dive. We are going on a mission to expose what is quietly keeping your supply chains and manufacturing lines alive.
Because it's often not what the executives think it is.
No, not at all. We're talking about the massive, completely hidden operational risks caused by undocumented Python scripts, Excel macros, and unsanctioned workarounds.
Right, what the industry broadly calls shadow automation.
Exactly, shadow automation. And I have to admit, looking over the industry data and the architectural frameworks we have for this deep dive, there is just this absurd disconnect.
Oh, a massive disconnect.
Like between the high-level tech trends you read about in business magazines and the actual, held together by duct tape realities of the plant floor.
Yeah, to really unpack that disconnect, we have a great stack of sources today. We are looking closely at data from the Control System Integrators Association, or CSIA.
Right.
And we've got deployment guides from Trout Software regarding zero trust network overlays. Plus, the strategic operating framework written specifically for, founder-grade system architects.
It's some heavy reading, but it is fascinating.
It really is. But we need to establish something critical right out of the gate here. These undocumented systems, these rogue scripts, they are not malicious.
Right. The people building them aren't trying to break things.
Exactly. The engineers building them are not trying to sabotage the company. I mean, these workarounds are a logical, almost inevitable response to structural failures within the organization's official architecture.
That makes so much sense. I mean, think about your own workplace, right? It doesn't even have to be a manufacturing plant.
Yeah, it happens everywhere.
Like, do you have a magic spreadsheet in your finance department? Or maybe a colleague who is literally the absolute only person in the building who knows how to run a specific daily report?
Oh, I guarantee someone listening is nodding their head right now.
Oh, 100%.
Yeah.
By the end of this deep dive, you're going to understand exactly why these shadow systems exist, the catastrophic risks they pose, and most importantly, how to fix them without breaking your business.
Because you can't just pull the plug.
Right. So let's unpack this. Why doesn't the C-suite know about this laptop under the desk? Like, how is there such systemic blindness at the executive level?
Well, the C-suite is fundamentally looking in the wrong direction.
What do you mean?
They are looking up at cloud architectures and, generative AI, while the foundation is literally crumbling in the basement. We really have to start by understanding this concept called the API deficit.
The API deficit. Okay, break that down for us.
So if we look at the reality of global manufacturing, over 70% of Tier 2 manufacturing relies on analog-era controllers.
70%. That's huge.
It's massive. We are talking about legacy PLCs, RTUs, and SCADA systems.
Hold on. Let's translate that hardware jargon. A PLC is a programmable logic controller, right?
Yeah.
These are the physical boxes, like the ruggedized computers that tell a robotic arm to move, or a massive industrial valve to open. They are the brains of the heavy machinery.
Spot on. And they are incredibly robust. I mean, they were built to last for decades, to operate in extreme heat, massive vibration, dust.
Yeah.
But their architecture is from a totally different era. These legacy analog machines just lack native REST APIs. They do not have modern, secure endpoints at all.
So they can't just connect to the Wi-Fi and send a clean data packet.
Right. In technical terms, they operate on serial protocols or really basic proprietary networks. They do not speak the language of the modern internet, so they cannot naturally talk to modern enterprise resource planning software.
The ERPs, like SAP or Oracle.
Exactly.
Okay, so just to visualize this, you have a physical machine built in, like 1998, that controls a vital part of the assembly line.
Yeah?
And it outputs, what, a raw voltage signal or some basic text string.
Basically, yeah.
And then upstairs, you have this beautiful cloud-based dashboard built in 2025 that the executives use to track production. And that dashboard requires, structured JSON data over a secure internet connection.
Exactly. And the two literally cannot communicate.
It's like they're speaking two totally different languages.
It is a massive analog to digital wall. And this brings us to the real irony of the current moment in business.
The generative AI stuff, right?
Yes. Right now, executives are allocating millions of dollars to draft generative AI governance and policies. They are hiring AI ethicists.
Which is crazy to think about compared to the factory floor.
Right. They're building LLM task forces and talking about the transformative power of artificial intelligence in their quarterly earnings calls.
It's just such a GenAI blind spot. Like, you have companies pouring budget into ChatGPT wrappers and AI drafting tools while the actual physical plant floor...
The place that actually makes the money?
Exactly. The foundation of their data relies on a fragile Excel macro written by a guy named Dave 6 years ago.
Yeah.
I mean, you cannot scale a cutting-edge AI operation if the underlying data feed is being held together by hidden macros.
You really can't. If you feed an advanced AI model with data that has been, scraped from a legacy screen by an undocumented Python script, your AI is operating on a fundamentally compromised data supply chain.
Garbage in, garbage out, basically.
Exactly. The strategic framework from our sources makes a really forceful point here. Organizations need to hit pause on chasing these GenAI policies until they know exactly how many Python scripts are secretly keeping their facilities online.
I hear that, but let's play devil's advocate. How do you actually force executives to look at the basement instead of the clouds?
It's tough.
Because AI is sexy, right?
Yeah.
It gets you on the cover of magazines. Auditing legacy PLCs does not. If an executive wants to deploy an AI agent to optimize supply chain routing, they want it done yesterday.
Well, you have to tie the two together. The sources suggest that AI usage policies absolutely must be tethered to an actual inventory of formal and, crucially, informal automated assets.
Oh, I see. So you hold the AI hostage, in a way.
Kind of, yeah. If leadership wants that AI optimization, the prerequisite must be a verified map of how the routing data gets from the analog machine to the digital database. The AI ambitions will just fail spectacularly if they don't secure those unsanctioned gateways first.
That makes total sense. But, okay, that sounds great in theory. But if these machines can't talk to each other natively, how is the plant still running right now?
That is the million-dollar question.
Right. If the 1998 machine can't talk to the 2025 dashboard, why is the dashboard showing 100% efficiency? Someone or something is acting as a translator in the middle.
And that brings us to the concept of the hero engineer.
Let's talk about the hero engineer. This is fascinating.
It's honestly one of the most interesting human elements of this whole ecosystem. The system integrator data points out that shadow automation almost never begins as misconduct.
It begins as initiative.
Exactly. An engineer on the floor sees that management needs faster production reporting. Or maybe a project manager realizes that manually reconciling job costs from the legacy machine to the new ERP takes 4 hours a day.
And engineers are, fundamentally, problem solvers. They hate inefficiency.
You really do.
So to integrate these legacy systems, the floor engineer just decides to write an unsanctioned Python script. Or they deploy a screen scraping macro. The sources mention tools like PyAuto UI popping up constantly in these environments.
Yeah, let's actually unpack how a screen scraper works because it really highlights the fragility of this whole setup.
Yeah, how does it actually function?
So a screen scraper is a piece of code that literally takes control of a computer's mouse and keyboard at the operating system level.
Wait, really? It just takes over the mouse?
Yeah. It doesn't use a clean API. It physically moves the digital cursor to specific X and Y coordinates on the monitor, clicks a button, copies the text on the screen, and pastes it into another application, and it just does that over and over again. Or, alternatively, the engineer builds this massive, complex Excel spreadsheet filled with Visual Basic macros to pull raw text files and parse them.
And you can see why the incentive to do this is overwhelming. I mean, the factory demands continuous uptime. The official IT architecture failed them.
Yep. IT deployed an ERP that couldn't talk to the machines.
But operations still demands the daily report. So the engineer just makes it work to keep the line moving.
They build a bridge.
It's like, imagine a city where the main highway is completely jammed because the official city planners totally messed up the intersection.
I love this analogy.
So a clever local resident just goes out in the woods with a machete and hacks a secret, unmapped dirt tunnel to bypass the traffic jam.
And it works?
Right, it works. The resident gets to work on time, and soon they are secretly guiding all the company's delivery trucks through this little dirt tunnel in the woods.
That is exactly the dynamic.
Yeah.
But we really have to look at the darker side of that scenario.
The risks.
Yeah, because we are dealing with asymmetric leverage here. Only that one resident has the map to the tunnel. In the factory, only the hero engineer understands how that Pyodoo GUI script actually works.
Right.
So what happens if the ERP software gets a minor routine update and the export button moves 4 pixels to the left?
Oh, geez. The screen scraper just clicks empty space.
Exactly. The script breaks, the data stops flowing, and the dashboard upstairs goes dark.
And who is the only person who can fix it? The hero engineer.
Yep. These knowledge silos basically act as the ultimate job security. The engineer who exclusively understands this fragile workaround gains massive asymmetric leverage within the organization.
They become a single point of failure.
Precisely. If they get promoted, if they quit, or even if they just go on a 2-week vacation, the entire integration dies. Management looks at the system and sees efficiency, but the floor looks at the system and sees terrifying fragility.
That is wild. So we have this environment where the workarounds are built out of absolute necessity, but they evolve into these massive hidden risks.
Yeah.
Let's get into the operational reality of what happens when they are left unchecked. How does a small problem on the plant floor escalate into a complete C-suite nightmare?
Well, it all comes back to a clash of civilizations within a company.
You mean IT versus OT?
Exactly. Information technology, or IT, the people managing the networks, the cloud, the ERPs, the laptops, and operational technology. OT, the people managing the PLCs, the robotic arms, the physical plant floor.
Right, their goals are totally different.
Completely different. IT demands security, compliance, governance, and constant software patches. OT demands one thing above all else: uninterrupted, continuous uptime.
I mean, you do not push a software update to a robotic arm handling heavy steel while it is in motion.
No, you absolutely do not. IT wants to patch the Windows server on Tuesday at 2 p.m. OT says if you touch that system, the line stops and we lose $50,000 an hour.
And shadow automation lives exactly in the friction point between those two mandates.
Yes, IT won't build the bridge because it's not strictly secure, so OT builds it secretly to maintain the uptime they're measured on.
Wow. So that secrecy creates what the sources call the 4 distinct pillars of hidden risk. We need to spend some serious time unpacking these, because this is where the true liability lies for leadership.
Definitely. These pillars are crucial.
Let's take one by one. The first pillar is business continuity. We touched on this with the hero engineer, but let's dig a little deeper.
Okay.
If a critical daily production process lives inside a single employee's personal desktop folder, literally like a file called daily report fix v3.p, what happens when that employee leaves the company?
The business continuity evaporates instantly. I mean, there is no version control, there's no manual, no standard operating procedure.
I think to the next guy to read.
Exactly.
Yeah.
When the process breaks the next day, the new engineer has to reverse engineer a completely undocumented script that is interacting with 30-year-old hardware.
That sounds like a nightmare.
It is. They have to figure out what libraries were imported, what dependencies exist, what the core logic even was. It can literally take weeks to untangle. And during that time, operations are effectively flying blind. The C-suite is making decisions based on 0 actual plant data.
Which perfectly leads to the second pillar, data integrity. And honestly, looking at the sources, this one might be the most insidious.
Oh, it absolutely is.
Because unverified scripts transform data without any transparency.
It completely compromises high-level decision-making. Let me give you a hypothetical but very realistic example.
Okay, lay it on me.
Let's say a Python script is pulling temperature data from a sensor on a chemical vat, but the analog sensor is old, so it occasionally throws a voltage glitch and outputs a negative number.
Right, a temporary error.
Yeah. So the engineer who wrote the script noticed this years ago, and they quietly added a line of code that says, if the temperature is negative, just report the average of the last 10 minutes.
Wait, really? So the script is actively altering the truth to make the report look clean?
Yes. It's silently dropping the anomalies.
Oh, wow.
Management looks at the dashboard and thinks the thermal control systems are perfectly optimized. They make financial and, more importantly, safety decisions based on that data.
But the data supply chain is fundamentally flawed.
Exactly. They're making decisions based on a hallucination created by a desktop macro. They think they are data-driven, but they are actually macro-driven.
That is terrifying. Which brings us to the third pillar, cybersecurity exposure. We are talking about all these unvetted low-code tools, desktop scripts, and local AI apps.
Yeah, think about the perimeter. When an engineer uses a free online tool or an unsanctioned AI assistant to help write a script to bridge a gap, they might be inadvertently opening a port on their machine.
Right.
Or they might be sending proprietary production data to some external server just to be processed. IT has firewalls and intrusion detection systems at the perimeter.
Supposedly, yeah.
But if the threat is originating from an approved user's laptop using an unmonitored script on the internal network, it bypasses the perimeter completely.
Because it's coming from inside the house.
Exactly. It is a completely unmonitored entry point for sensitive operational data. It can act as a reverse shell, giving an external attacker a direct pipeline right into the OT network.
And that ties into the fourth pillar, compliance gaps. If you are in defense manufacturing or pharmaceuticals or utilities, undocumented processes just completely undermine your audit readiness.
Oh, compliance auditors will have a field day with this. Take pharmaceuticals, for example. The FDA requires strict adherence to electronic record regulations, Title 21 CFR Part 11.
Basically proving your data is real.
Right. You have to prove an unbroken, verified chain of custody for your data. You cannot prove to an auditor how your batch data is generated if the answer is, Dave's hidden laptop runs a script that grabs it.
Yeah, that won't fly.
In highly regulated industries, failing an audit doesn't just mean a fine. It can literally mean losing your license to operate. The shadow automation completely circumvents the formal control structures that compliance requires.
So, hearing all of this, the logical, immediate reaction from any IT director listening to this deep dive is going to be, find it and kill it.
Yep. The SWAT team approach.
Right. Like, if IT discovers a rogue Python script running on the floor, shouldn't they just isolate that machine, put it on an air-gapped VLAN, and shut the script down immediately to protect the network?
No, absolutely not. That is what the framework calls the break-to-fix paradox.
Why not?
If you kill the unsanctioned gateway, you break the plant.
But wait, if it's a massive security risk, isn't the risk of a breach worse than the risk of some downtime?
You are assuming the business can survive the downtime. That security risk is currently serving as the load-bearing pillar for your entire production schedule.
Oh, I see.
Bringing shadow code into compliance usually requires shutting it down so you can audit it, document it, and secure it, right?
Yeah.
But the moment you shut it down, you instantly halt the very workflow it was secretly sustaining. IT comes in like a SWAT team, unplugs the rogue laptop, and suddenly the shipping department can't print labels. The finance department can't bill clients. And the assembly line shuts down because it's waiting for a reconciliation report that just no longer exists.
The cure kills the patient.
Exactly. You cannot treat shadow automation merely as a security violation. You have to treat it as critical, albeit fragile, infrastructure.
Okay, so if we can't just unplug these systems, and we obviously can't leave them alone because they are a ticking time bomb, how do we find them safely?
That's the real challenge.
Let's get into the discovery phase. If I am an IT director or maybe an operations manager, how do I spot these informal workflows without triggering a panic on the floor? Because, I mean, if I walk out there with a clipboard and ask people what unsanctioned code they're running, they are going to lie to my face.
Oh, they absolutely will, because they are protecting their systems and their jobs. The Discovery Toolkit starts with a major conversational shift.
Okay, like what?
IT needs to change its posture from being an enforcer to being an investigator of friction. You have to ask questions that focus on the pain points, not the rules.
Give me some examples. I know the prompt mentioned we need to list specific discovery questions an IT team should ask to spot these workflows.
Okay, so you ask things like, hey, when the ERP went down for maintenance last month, how did your team manage to keep the shift logs updated?
Oh, that's sneaky. Because it forces them to explain the workaround.
Exactly. Or you ask, I see the legacy PLC outputs a raw text file, but the dashboard upstairs shows a polished pie chart. Can you walk me through the exact steps of how it gets from A to B?
You are looking for the discrepancies.
Right. You are looking for the gap between manual overrides and the final dashboard outputs. You are trying to spot where AI tools or macros are silently influencing the operational decisions.
You are looking for the magic. When something happens that shouldn't be technically possible based on the official architecture diagrams, you know there is a shadow script making it happen.
Bingo. And the primary place to look, and this is a key takeaway, is the data handoff.
The handoff.
Yes. Look closely at workflows that are managed by or dependent on a single individual's desktop. Where does the analog machine's data go right before it reaches the digital ledger?
That space between the physical machine and the corporate network.
That layer, that is the API bridge. That is the ultimate control point. Whoever owns that handoff literally owns the operational truth of the facility.
Okay, let's say we do this. We run a 30-day IT audit of shared drives and individual workstations on the plant floor. Not to delete anything, but simply to quantify exactly how many critical reports rely on single-user, undocumented macros.
Just to find the scale of the problem.
Right. If you ran that test in most Tier 2 manufacturing plants tomorrow, what is the realistic scale of what you'd find?
Honestly, you would find dozens, if not hundreds, of these micro-automations.
And hundreds.
Easily. You would find that the official multi-million-dollar software suite is entirely dependent on a massive web of fragile Excel files and Python scripts. It is a deeply humbling exercise for any executive team.
I bet. Yeah. So, okay, we run the audit, we find the scripts. We find Dave, the hero engineer, and his 10-year-old laptop. Now we have a really delicate situation.
Very delicate.
We had to deal with the engineers who made these workarounds. How do we do that without creating a culture of fear, secrecy, and resentment? Because if Dave feels threatened, the next time he builds a secret tunnel, he is going to hide it even better.
Exactly. And this requires a profound shift in philosophy. We have to look at the concept of restorative engineering.
Yes, this is a fascinating part of the framework we read. There's a story in the sources about an engineer years ago who was watching factory workers handle live explosives.
Yeah, grenades on an assembly line.
Right, grenades. The engineer noted that the workers were handling these explosives as if they were literally holding their breath. The tension in the room was palpable. The physical stress was immense.
Naturally.
So this engineer built a process using a collaborative robotic arm. I think they called it a TechMan cobot. But they didn't build it to generate a massive financial ROI for the company or to get headlines about AI disruption.
No, the motivation was totally different.
They built it for one specific reason, so that at the end of the shift, those human workers could send a message home to their family saying, "I'm safe tonight."
That story perfectly encapsulates the core lesson here. Real technology does not replace people. It restores them.
It restores them. I like that.
It restores their safety, their capability, and their dignity. When we apply technology just for the sake of efficiency, we often treat humans as a variable to be eliminated. But when we apply technology restoratively, we are using it to absorb the risk so the human doesn't have to.
So how does the grenade story apply to Dave and his Python script? It's not a physical explosive, obviously, but it is an operational explosive.
We apply what the framework calls the principle of restorative visibility. When you find Dave and his script, the absolute worst thing you can do is penalize him.
Right.
You must not punish the engineers who built the shadow systems. You have to recognize that they were solving a structural failure of the organization. The company failed to provide an API, so Dave built a bridge to keep the company's lifeblood flowing.
Because if you punish him, you are punishing initiative. You are punishing the very thing that kept the executive dashboard at 100%.
Exactly.
But obviously, you also can't just let him keep running it in secret. So how do we incentivize documentation without discouraging that employee innovation?
You change the incentives. Currently, the entire manufacturing system optimizes for uninterrupted production. If uptime is the only key performance indicator that matters, the system will naturally breed shadow automation.
Because shadow automation is the fastest way to fix a roadblock.
Exactly. To fix the culture, you must change the incentive to reward the legibility of the system.
So you reward them for making the system readable, understandable, and mapped out.
Yes. You go to Dave and you say, look, the script you built is brilliant. It saved the company countless hours, but right now it is a risk because only you know how it works. We want to formalize your work. We want to make you the official architect of this bridge.
Well, that's smart. You don't make the hero engineer the scapegoat for IT's failure. You elevate them to be the architect of the solution.
Right. You give them the resources to rewrite the script in a secure environment. Put it in version control like GitHub, and document it so the whole team can use it.
You are taking the shadow out of the shadow automation, but you are keeping the automation. You are restoring the engineer's work into the light.
Exactly.
Okay, so we have the right mindset. You're not going to fire Dave. We know what to look for. the data handoffs. Now let's get deeply technical.
Let's do it.
How do we actually deploy a technical solution to map and formalize these assets without taking down the active production line? We need a practical roadmap here because we still have that break-to-fix paradox to deal with.
Right. We know we can't just install heavy security software on 30-year-old analog machines. We have to respect the physical constraint of legacy tech.
Because if you install an agent on an old PLC,
It will crash immediately. In the cloud, zero trust is a relatively solved problem. You just put an agent, a small piece of monitoring software, on every workload. Identity is verified everywhere.
but on-premise, on the physical factory floor, the local area network, the LAN, it still runs on implicit trust.
Yeah. Once you are plugged into the network switch, you can basically talk to anything else on that switch. And like we said, you cannot run modern security agents on a legacy PLC from 1998. It physically does not have the RAM or the processing power.
And if you try to do a massive network refactoring, like physically rewiring the whole plant to segment the network and put firewalls everywhere, you're looking at days or weeks of downtime.
Which operations simply cannot afford.
So what is the technical workaround? How do we inventory these rogue scripts without disrupting active production lines?
The answer is not to change the legacy equipment at all. The answer is to use agentless zero-trust overlays.
Agentless zero-trust overlays. Okay, break that down mechanically. What is that actually doing at the network level?
You are deploying a localized Edge AI node directly into the existing LAN switch, usually via what's called a span port or a tap interface.
Okay.
It requires no software agents installed on the end devices. It requires no physical rewiring of the plant. And crucially, it requires zero downtime to deploy because it sits out of band.
So it's basically sitting on the side of the highway watching the cars go by rather than setting up a toll booth that stops traffic.
Initially, yes. It builds an overlay on top of the network. Eventually, it enforces identity, microsegmentation, and access control at the network level, acting as a proxy. But before it enforces anything, it has to learn.
Which brings us to the phased plan.
Right, the discovery as a service model.
Walk us through this phased plan, because this is the actionable roadmap for cataloging shadow assets. Let's say week 1 is all about visibility. What is the overlay actually doing technically during week 1?
During week 1, the overlay uses passive NetFlow monitoring and deep packet inspection. It does not block any traffic. It just watches the packet headers flowing across the network.
Just observing.
Right. It automatically discovers assets across all the VLANs. It starts building a real-time inventory of everything communicating on the floor based on MSC addresses, IP addresses, and protocol types.
And this is where the skeletons come out of the closet. The system watches the traffic, and suddenly the overlay spots things that absolutely shouldn't be there.
Oh yeah, you plug it in and suddenly the dashboard flags a rogue connection labeled admin HTTP, pulling 500 megabytes of data across a segment that is supposed to be quiet.
Or it spots an undocumented temp sensor doing 250 megabytes of traffic on a strange port.
Exactly. Or it spots a legacy PLC hashtag sitting right on the OT network, broadcasting unencrypted serial data to a random IP address that turns out to be Dave's laptop running the screen scraper.
That is the moment of truth. You have mapped the shadow ecosystem.
You now understand the actual data flow, not just what the official architecture diagram says. You have protocol-level visibility across both IT and OT, achieved passively without disrupting a single operation.
You have your inventory.
You have your inventory?
We have the map. We see the secret dirt tunnel in the woods. Now comes the transition. How do we fix it without breaking the plant?
You slowly bring the unsanctioned scripts under formal version-controlled architecture. You don't delete Dave's script immediately.
Right, no SWAT team.
No SWAT team. Instead, you build an official API bridge alongside it. You use the traffic data you gathered from the overlay to understand exactly what the payload looks like. You test the official bridge to ensure it handles the exact same data the shadow script was handling.
You essentially build a modern, secure highway right next to the secret dirt tunnel, while the dirt tunnel is still actively in use.
Yes. And once the official API bridge is fully tested and verified, you configure the overlay to route the traffic through the new secure pathway. Then and only then do you quietly decommission the fragile macro.
You replace the duct tape with steel, quietly, without ever stopping the line.
It completely sidesteps the conflict. IT gets their security, compliance, and version control. OT maintains their precious continuous uptime, and the hero engineer is integrated into the formal development process instead of being marginalized.
It is the absolute embodiment of restorative engineering applied to network architecture. You are
Hmm.
securing the base and making the system legible, which creates an asymmetric advantage.
Yeah, the companies that map their shadow systems early will be the ones capable of actually stealing advanced AI because their data foundation will be solid, not built on sand.
This has been such a revealing journey. If you are listening to this right now, whether you work in manufacturing, finance, marketing, or logistics, shadow automation is happening in your company.
Without a doubt.
Someone, somewhere, is using an undocumented macro or a rogue Python script to bridge a gap that the official software missed. The question you have to ask yourself is, are you building the future of your company on top of hidden macros? Are you trying to scale a fracture?
Undocumented automation isn't a sign of employee malice. It is a signal that innovation is happening faster than governance. Your people are trying to solve problems. But relying on shadow IT means you are externalizing risk.
And as the sources pointed out, the strongest businesses capture control points. They don't just chase attention with flashy AI dashboards.
The layer that connects the analog reality to the digital ledger, that API bridge, that is the ultimate control point.
I want to leave you with a final lingering thought to mull over today. We started by picturing that flawless executive dashboard. Now think about your own department. Think about the daily reports you rely on, the metrics you use to prove your success.
Think about where that data really comes from.
Exactly. If you were to randomly unplug one 10-year-old laptop in your office today, how much of your department's supposedly automated reporting would instantly collapse? Map your shadow networks, secure your base, and build systems that can actually survive contact with reality. Thank you for joining us on this deep dive, and we will see you next time.